Okay, I'm recording, just so you guys know, I forgot to record on Friday, my other 1010 class. And this is long, okay? You're gonna wanna really stay focused. This will be on the quiz, and I don't think it's super easy. I think it can get a little bit confusing. So just stay so close with me, okay? Okay, here are 4 rules that you have to remember, okay? So look at the first rule, you guys. You have the nth root of x, and that is raised to the x, that is raised x to the 1 over n is what that's equal to, okay? So everybody do this. Everybody write the cube root of b. This inside exponent on the b is a 1. So that's called radical form. Square root means, some kind of a root means radical. This is a fractional exponent. You put your b, and do you see how that exponent is a 1 right there? That goes on the top, you guys. And that little number right there is a 3, so that's just equal to b to the 1/3. Okay? Yeah, let's do it. So let's do the cube root of z squared. So that's going to be a z. The bottom number is a 3 because it's a cube root. The top number is a 2 because it's raised to the second. Okay, so maybe on this side, guys, put radical. And on this one, put fractional exponent. They're going to tell you how to write it, so you have to make sure you know which is which. Okay, okay, so rule number 2 is pretty easy. If they're together and the root is the same, you can write them separately. Or if they're separate, you can pull them together. Let me give you an example, okay? The square root of 8 times the square root of 2. Those two things are separate. You guys, is the square root of 8, everybody tell me, is the square root of 8 a nice number, like 1, 2, 3, 4, 5? No. Is the square root of 2 a nice number? No. So I'm just going to pull those together. They both have a square root, so I'm going to pull them together. 8 times 2 is 16. What is the square root of 16? 4. So sometimes they're separate and it's tough, but when you pull them together, it's like really clean. Okay? Look at this one. Same thing with division. If they're separate, you can pull them as 1, or if they're 1, you can separate them. Okay? So I'm going to do 2 examples on this one. Okay, so here's one example. If you have the square root of 8 over the square root of 2. The square root of 8 is not a nice number. The square root of 2 is not a nice number. But if I pull those together, the square root of 8 over 2, 8 over 2 is a 4. So that's really the square root of 4. And the square root of 4 is 2. Okay, the other way is true. If they're together and it's ugly, you can separate them. Look at this. The square root of 16 over 9. Well, guys, 16 over 9 does not reduce. So it's not going to be clean. But you know what I'm going to do? I'm going to separate them. So I'm going to write it as the square root of 16 over the square root of 9, and that's really clean. Square root of 16 is a 4, square root of 9 is a 3, and you're good. So if they're together, you can separate them. If they're separate, you can pull them together, and it could be easier the other way. Okay? Okay, so this one right here, so this thing right here we already talked about, fractional exponent. And then this thing we actually did not. Okay, so I'm going to try to make this nice. Okay, so a good example. Here's an example. If you have a 16, let me think about this. 16 to the 3rd, and it's a square root. Actually, I want you to write it as 16 to the 3 over 2. So everybody just write 16 to the 3/2. That's a fractional exponent. Okay? So this 2 tells you that you make your radical and that little number is a 2. Okay? Okay, now this is just a teeny bit confusing, so I want you to listen. What goes on the inside is a 16. You would typically put the 3 here. But if you put the 3 there, it's actually going to be tougher. So this is what I say. Everybody in the room answer this question. Is the square root of 16 a nice number? Tell me that. It is. It's a 4. Okay, so everybody listen. If it's nice, if the weather is nice, if it's 75, when you guys get out of school, when I get out of school, what do we want to do? We want to go outside. So if it's nice, you go out. So this is nice. So instead of putting my 3 in, I'm going to put it out. It was nice. It was correct if it was inside, but it's easier if you put it outside. Okay? And then the square root of 16, you guys, is a 4. So this is just 4 to the 3rd, which is 64. Okay? Okay, let's go ahead and jump into this and do some examples, okay? Okay, everybody in the room tell me what the square root of 64 is. It is an 8. 8 times 8 is 64. Write your answer down and you're done. How about the cubed root of 64? Okay, everybody in the room grab your calculator for me, okay? You guys, you should automatically, when you come to class every day before the bell rings, put your phone in the phone box upside down and take your calculator out. Like it should just always be out because we're almost always going to use it, okay? Okay, everybody listen how you put this in your calculator. Everybody go 3 and then hit second. And then you're going to hit this arrow up button. You're going to hit that caret button, which is down 4 buttons. And then you're going to put in 64. And then you're going to hit enter, and you get a 4. 4 times 4 times 4 is 64. So that makes sense. Okay? How about the cube root of negative 64? Okay, I'm going to tell you something that's super important. So I want you to listen. This is not an I. The reason that it's not an I is because this is odd. So everybody listen. If you have an odd root with a negative sign right there, I want you to pull the negative out and make it look like that as your first step. You can always do that if it's odd. So just make it easy on yourself and do it. Okay? And then we just found out that the cube root of 64 was a 4. So I'm going to replace that with a 4. But don't forget there was a negative sitting out in front of it, and it looks like that. Now you could figure that out on your calculator, so let's practice, okay? Everybody hit 3, then hit second, then go down 4 buttons, then hit the white negative button, 64, enter, there's your negative 4, okay? So you can do it either way, but you guys are smart enough, you don't need to do it on that calculator. Okay, somebody talk to me about the square root of negative 64. What does this negative do right here? What does it make? It makes an I, yes. The square root of a negative number is an I. And then the square root of 64 is an 8, so that's actually equal to 8i, okay? We haven't talked about imaginary numbers. You're not going to have imaginary numbers on quiz 2, and I really don't think that they're going to be on the midterm because we haven't gone through them yet, okay? Okay, everybody in the room, look right here. This is actually the exact one that I did for you. Is the square root of 8 a nice number? Talk to me. No, square root of 2 is not nice, right? So let's pull those together. So 8 times 2 is 16, and the square root of 16 is a nice number. It's a 4, and you're done. Easy, right? Look at question F. Does 9 reduce with 25? No, I can't reduce that. But I can deal with them separately, guys. Look, that's the square root of 9 over the square root of 25. The square root of 29, or pardon me, the square root of 9 is a 3. Square root of 25 is a 5. That's my answer, and I'm done. Who says I get this? Let me see. I feel good. Great. Everybody look at 75. Look at that number, 75. Is the square root of 75 a nice number? What do you think? 7 squared is 49. 8 squared is 64. 9 squared is 81. I skipped over 75. So no, it's not nice, right? Everybody write down 75, and let's break it down. So 75 is 3 times 25. 25 is 5 times 5. These two 5s come out as a single 5. So I have a minus 5 on the outside. It's a minus because it was a minus to begin with, right? And I'm going to leave some room, and then inside I still have a 3. Do you see how I deal with the numbers and then I move on to the variables, right? So look at the x's. This is a square root. Remember that. So how many times does 2 go into 3? One time. Does it go perfectly, you guys, or do we have remainders? We have remainders. How many remainders do we have left over inside? Just one. That's it. That's your answer, and we're done. Who says, I'm good with this? Let me see. Yay. Okay, so question H, there are multiple ways to do this. I'm just going to multiply those insides together, okay? So I'm going to make this the cube root of negative 12 times 2 is negative 24. The A is to the 4 times 2, which is a 6. The B is to the 3 plus 2, which is a 5. Now, see the negative that's with the 24? Since that's an odd root, I'm going to pull that guy out right there, and I'm not going to worry about him anymore. He's out. Is the cube root of 24 a nice number? What do you think? We're kind of more difficult, right? Let's just break it down. So 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. You guys, this time, in order to pull things out, I have to have 3 of them. So these 3 2's come out as a single 2. So I have a negative 2, and then I have a cube root of 3. I've done my numbers. Now let's do the A's. 3 goes into 6 exactly 2 times, so that's an A squared. No leftover A's. Look at the B's. 3 goes into 5 one time. How many leftover B's do I have on the inside, everybody? 2. Yep. That's your answer, and you're done. Who says this? I don't know what you're talking about. Tough? Because I think this is easy. Raise your hand if you feel like that. Okay. Good. Good. Let's keep going. 8 to the 1/3. Everybody talk to me for a second. Is that written as a radical, or is that written as a fractional exponent? Fractional exponent, right? So see the 3 that's on the bottom, guys? That's going to go right there. And then inside you have an 8 to the first power. You guys know you don't have to put that first power, though, right? What is the cube root of 8? Can you tell that off the top of your head? That's a 2. Yep. You have to go all the way and simplify it as much as possible. Okay? Look at question J. Can anybody tell me what you would do first? What would you do? There's so many. What about this? Everybody look right here for a second. Just watch me for a sec. Look at this. The square root of 12x to the 8th over the square root of 3x to the 3rd. You could simplify those roots and then multiply. You could also come like this and multiply top and bottom by 3x to the 3rd and then simplify. Those are all acceptable and perfectly fine. But I think it's not the easiest way. Can anybody see an easier thing? Go ahead, Hope.
Could you divide the 12 divided by 3?
Yeah, you can reduce that. Yeah, 12 over 3, you guys, is a 4 on the top of a fraction, right? Look at the x's. 8 on top, 3 on bottom. Where do you have more on top? How many more? 5 more. Am I done? A lot of people go, woo, done. Are we done? What's the square root of 4? 2. No more numbers. It's just a 2. And then 2 goes into 5 exactly 2 times. Do I have leftovers? I do. A square root of, tell me, x. That's so much easier than the other method that I started doing, right? You're going to get the same answer. But if you can see that that reduces, you guys, it's so much easier for you. Okay, here we go with question K. See that 4 right there on the bottom, guys? That tells you it's a 4th root. Then inside is 16, a to the 8th, b to the 16th. Everybody talk to me. Are we done? No. Do you know off the top of your head what the 4th root of 16 is? It's a 2. 2 times 2 times 2 times 2 is 16. Yes. If you don't know, break it down or use your calculator, but it's a 2. 4 goes into 8 exactly 2 times, no remainder. 4 goes into 16 exactly 4 times, no remainder. If there's nothing left inside, you don't write the radical anymore. What are you going to do? Write the radical of nothing, right? That doesn't make sense. So it's gone. That's it. Who says I'm totally with you? Raise your hand. Let me see. Okay, good. Okay, question L. So many different ways to do this. I'm always going to show you the way that I think is the easiest. Does anybody have any idea what you would do? Like, think of last time's lesson. What would you do? I would go power to a power rule. What do I do to those exponents on the power to a power? Do you remember? You multiply, yes. So you have a b. Here's how you multiply fractions, you guys. You multiply the tops together and the bottoms together. So a -1 times a -2 is a +2. 3 times 3 is 9. Don't write your answer as a fractional exponent unless they tell you to, which they have not. So now I have to write it as a radical. So it's the 9th root of b to the 2nd. That's my answer, and I'm done.
So would you not simplify the 2 9s? Oh, just because you can't do that.
Yeah, if it was 2 4s, you would reduce it to 1/2. Yes. So if that 2 9s reduces, then you should. Okay. Okay, here we go. Question M. Okay, nice and slowly. Cube root. Inside you have a -27. Everybody freeze. This is kind of what I talked about very briefly on the little rules section. I have to put a 2 somewhere. Everybody tell me, is the cube root of -27 a nice number? What do you think?
Yeah.
It is nice. So if it's nice, we want to go outside, right? So put your 2 outside, like that. Now, let me make it easy on you. Look right here. See the negative? Let's get rid of it. I'm going to put the negative, and I'm going to put it right there. It still has to be squared. I wouldn't put it outside of the parentheses, but I'm going to pull it outside of the radical. Okay? Now, so this negative is going to be sitting there. Everybody in the room, tell me, what is the cube root of 27? 3. Good. So it's a -3 squared. Are the parentheses in that -3 squared necessary? Yes, they are. Yes, they are. Because that means a -3 times a -3, which is a +9. That's your answer, and you're done. Is this stuff going to be on the quiz? Yes, it is. Look at question N. The second you look at it, something really stands out to you. What is it? The negative exponent. So I've got to pull that negative exponent. Since right now it's on the top, I have to pull it down to the bottom. Okay, so on the bottom, it's going to be a 16 to the +3/2. Somebody tell me what we have on the top. A 1. Good. Now I'm going to make it a radical. See the 2? That tells me I have a square root. Then inside I have a 16. Guys, I can put the 3 right here, or I could put it outside. Is the square root of 16 a nice number? Yes, so I'm going to put it out. What is the square root of 16, everybody? 4. So it's 1/4 to the 3rd. 4 to the 3rd is 64. My answer is 1/64. Okay, here's O. Lots of different ways to do it. What I would do is I would take care of the ugliest thing first. What's the ugliest thing? I would bring that negative up. That's me. Lots of different ways to do it. Okay, so I would say that's xy to the 6th raised to the 1/2. This is last time's lesson. Power to a power rule. X to the 1st to the 1/2. Yes. Oh, yeah. Thank you. X to the 2nd raised to the 1/2. Y to the 6th raised to the 1/2. What do I do to those exponents? Tell me with one word. Multiply. Good. So the x is raised to the 2 times 1/2. What is 2 times 1/2? It is 1. And then the y is to the 6 times 1/2. That's like 6 divided by 2. That's what that means, which is 3. That's your answer, and you're done. Okay? Here's this one. Now, this is especially ugly. So, lots of things I could do. what I'm going to do is I'm going to raise them both separately to the negative 2/3. So look what I'm going to do. I'm going to put the negative 1 in parentheses and raise it to a negative 2/3. Then I'm going to write down the 64 and raise it to the negative 2/3. I don't have to put the 64 in parentheses because it's not a negative, okay? I could put it in parentheses, but I don't need to. Okay, now both of those things have negative exponents. So the 64 to the negative 2/3 is going to come up and become a 64 to the positive 2/3. On the bottom, I have a 1 to the positive 2/3. Guys, talk to me about this. 1 to any power. 1 to the first, 1 to the second, 1 to the third, 1 to the negative first, 1 to the negative 1,000, 1 to the millionth. What's it always equal to? Just a 1. So forget about that. So just look at that 16 to the 2/3. It's going to be a root. Everybody in the room, tell me what's the little number I'm going to write right here. It is a 3. Yes. Then I put a 64. Now I don't know where to put my 2. Is the square root of 64 nice? Yes or no? It is nice. So I'm going to put my 2 on the, talk to me, on the outside. Good. 2 to the third is, or the cube root of 64 is 2. 4 squared is 16. That's my answer, and I'm done. Okay? All right, that was P. Here's Q. Everybody in the room, talk to me for a second. Look, is this negative okay? It's fine. The negative exponent right here is not okay. So look how I'm going to do this. I'm going to write this as the cube root of negative 27. The x to the negative 6 comes down and becomes an x to the positive 6th. Is that right? It is not right. What's wrong with it? It's in a root. Yeah, so be careful. This is in a cube root. Okay, now watch this. I'm telling you, if you can remember this little trick, you guys, look. It's going to make it so much easier. Look, see this negative right here? And that's an odd. Get rid of the negative and write it on the outside. Put a negative. What is the cube root of 27, everybody? 3. What is the cube root of x to the 6th? X squared. 3 goes into 6 2 times. That's my answer, and I'm done. Okay, here's R. All right, now this one is tougher. Okay, everybody just listen for a second. Just kind of kick back and watch this. Look, if you have p to the 3rd over p to the 5th, that's equal to, what does that reduce to? 1 over p squared. How did you get that? How did you get that squared on the bottom? What did you do? Subtracted the exponents. You have more on the bottom, so they're left over on bottom. How many more? 5 subtract 3 is a 2, right? So look at what we've got on this guy, okay? We are going to have to subtract those exponents. But I can't subtract fractions unless I have a what, everybody? Common denominator. So we're going to get a common denominator, okay? So everybody write a p over p. Now look at those denominators, you guys. They are 3 and 4. So my common denominator is going to be, can you tell me?
12.
It is going to be a 12, yes. Okay, now everybody watch this closely. Watch this. I'm trying to turn 1/3 into something over 12. Watch how you do it. 3 times 4 is 12. So 1 times 4 is 4. And I know that's right because if I reduce 4/12, I get 1/3. So I know I did that right. Okay, let's do the next one. 3/4 into something over 12. So I go, okay, 4 times what is 12? That would be 3. So 3 times 3 is 9. If I have, think of a pizza. Okay, everybody listen. Think of a pizza. Cut into 6 slices. Somebody on the top has 4 of their 12 slices left. Somebody on the bottom has 9 of their 12 slices left. Who's got more, top or bottom? Top or bottom? 4 slices versus 9 slices. Bottom, right? So everybody put them left over on the bottom. On the top, you're just going to have a 1. And what you have on the bottom is something 12ths. How many more slices do you have on the bottom than the top? 5. That's your answer. We're going to leave it like that. There's a lot of different things we can do. You don't know where to stop, okay? I'm just going to say stop right there, as not to confuse you. Okay, look at this one. You're multiplying. If you have this, guys, look, m to the second times m to the third, that gives you an m to the, tell me, fifth. I have to add the exponents. Look at those exponents. Can I add those together? Why not? Don't have a common denominator. What's my common denominator going to be, guys? 15. Good. Look right here. 3 times 5 is 15, so 1 times 5 is 5. 5 times 3 is 15, so 2 times 3 is 6. Now I'm going to add those. You guys, the bottom stays 15, and the top is 6 plus 5, which is 11. So I have an m to the 11/15. Now let's write that as a radical. So let's write it as the 15th root of m to the 11th, and I'm done. Okay, who says I'm okay? Raise your hand. Let's see. It's okay. It's just a lot of stuff. Okay, these now you're going to put in exponential form. Fractional exponents. These are quick and easy, so everybody watch. This a, write your a down, and it's going to be raised to the bottom numbers of 5 because it's a fifth root. What's the top number, everybody? 2/5. So that's an a to the 2/5. There's not a lot to do on that. Look at the next one. This is an m to the 2 over, talk to me guys, 4, and then you have an n to the 3 over 4. This will be worth 3 points, and if you stop right there, you're going to lose 1 point. Can someone tell me why?
Because it's a half.
Yeah, 2/4 reduces to a half. Good. So this is m to the 1/2 times n to the 3/4, and you're done. Oop. Okay, next one. Okay, this is tough. This is tough, so I want you to look. Just kick back and talk to me for a second. Look right here. If you had 2 plus x over 4, this is really important, okay? Look, guys. Look right here. Here's a person. Here's a person. Here's a person. There are 3 people. They're all best friends. You have your best circle of friends has 3 people in it. So if this person right here and this person right here, if they go to the movies and they don't even call this person right here, is that nice or is that rude? That's rude. So look, if you do this, don't write this down. If you go 2 goes into 2 once, 2 goes into 4 2 times, so that gives me 1 plus x over 2. That is not right because it's rude. Who is it rude to? The x. You have to include everybody. Okay? Now, look at this. If you had 2 plus 6x over 4, now you could do it because all 3 people can go to the movies. 2 goes into all those numbers. So 2 goes into 2 1 time, 2 goes into 6 3 times, 2 goes into 4 2 times, and now it's good. Who says I'm with you? Raise your hand. Okay, same kind of idea right here. That is not 2 separate terms. Together, it's one thing. It's one thing. Okay, so when you look at that, this is what I want you to see. The cube root of z. Do I have 3 z's that I can pull out as a single z? No. You can't pull out the a and then pull out the b. You can't do it. They want you to write this as a fractional exponent, you guys. So you go a plus b. How many a plus b's do I have? 1 over 3. That is literally your answer. Compare it to this, okay? Off on the side, I want you to write the cube root of a times b. That's different. The A is not stuck to the B on that problem. It is stuck on the real deal. Put 1's right here. So that would be A to the 1/3 and B to the 1/3. If they're added together, it's considered one thing. Who says, I understand what you're saying? Raise your hand, let me see. Okay, great. That's a big concept. Okay, right here. This 2 is raised to the first, and the Z is also raised to the first. I'm going to deal with this 1, 2, 3, 4 times. So you have a 2 to the 1/3. Then you have an X to the 2/3. And then you have a Y to the 3/3. And then you have a Z to the 1/3. That is not your answer. What do I need to do? Simplify what? The 3/3 is really just a 1. So you can just erase it if you want to, and then that's your answer. Just erase that 3/3, and that's it. Okay? All right. Questions? 3, 4, 5, 6, and then we're done. Okay? You guys, Weber State loves to ask you these questions. Is this equal to this? Why not? So we've done it before, and I'm telling you right now, when you do it, figure out what this one is, figure out what this one is, and then talk about why or why not they're equal to. Okay? So everybody write the cube root of -125 is equal to the negative cube root of 125. Is that true? Okay, look, see this negative right here? Pull it out. So put it right there. And then the cube root of 125, if you punch that in your calculator, or you can just think about it, it's a 5. So it's -5 equals this guy right here, -5. So that's true. How about this one? Negative square root of 25 is not equal to the square root of -25. Why not? Well, look at this. Negative square root of 25 is a 5. What do I have on the right-hand side? Can anybody tell me? That is a 5i. Good. Okay. So why are those not equal to each other? I'm going to say if you have a negative inside of a square root, comma, that is an I. I think that's acceptable. Okay. Choose values for A, B, and C to determine if this is true or false. Okay. Let's let A be 2, so we have a square root. Let's let B be a -16, and let's let C be a -25. So let's see if it's true. So you have the square root of -16 plus the square root of -25 is equal to the square root of -16 minus 25. Put B and C together. The square root of a -16 is 4i. The square root of a -25 is 5i. When I add those together, I get 9i. On the right-hand side, that gives me the square root of -41, which is equal to I, just pull that negative out as an I, square root of 41. Are those equal to each other? No. So I'm going to say not equal to each other. Okay, didn't ask me to write anything or justify. Okay, explain how to evaluate this. You guys, if I were you, I would evaluate it, and then I would write what I did. Okay, so everybody write cube root. Inside goes a -27. Everybody in the room tell me, is the cube root of -27 nice? Yes or no? Yes, it is. So the 4 goes outside. Okay, look right here and tell me if this is right or wrong. Everybody watch. This negative, I know can come out as a negative, so I'm going to put it right there. Is that right or wrong? It's wrong. Why is it wrong? Where's it supposed to go? supposed to still be to the 4th power, so you got to put it there, right?
Would it still be okay if you just left the negative inside?
It would be, because if you just do this, everybody freeze for 2 seconds. I really like your question. Everybody do this. Let's punch in the cube root of negative 27. Everybody go 3 seconds, hit that arrow button up, negative 27, enter, and you get negative 3. So this is a negative. Cube root of 27 is 3, and it's raised to the 4th. So you can do the same thing on your calculator, but if you have A's and B's and stuff like that, you can't do it on your calculator. Or if it's not a perfect root, like if it was the cube root of like 54, you're going to pull some out, but you're still going to have some left over. Does that make sense? Okay. The 4th root of negative 3 is negative 3 times negative 3 times negative 3 times negative 3, which is a positive 81. Okay. Now they're explaining how to write that. Okay. So they say explain. So I'm going to say first, write the expression as a cube root raised to the 4th power. Next, comma, replace the cube root of negative 27 with negative 3. Last, negative 3 to the 4th is 81. Do you see how if I do it and then try to write down the sentences, it's easier because I can just look at what I did? Okay, I'm telling you, Weber State loves these questions. Compare this to this, evaluate this, write up a sentence. So just be prepared for that, okay? Can I add these together? Well, the roots aren't the same, right? Look what you have, you guys. You have a b to the 1/9, pardon me, b to the 1/10 added to b to the 1/9. Those aren't the same exponents. They don't have exactly the same number of b's, so I can't do it. You know, the easiest explanation is they are not like terms, comma, because one is a 10th root and the other is a 9th root. That's it. Okay? Hey guys, here's a great thought. Listen to this. Wednesday is a tutorial. It's not going to work. You go period 5 and then tutorial, don't you? Darn. I was thinking it was tutorial and then 5. I was like, everybody come to tutorial and I can help you study right before you take the quiz. It's not going to work out. Never mind. Tutorial will be right after you take the quiz. Okay,